Hi and welcome to another very exciting tutorial, again in the 24 Days of Swift Tutorials series, and we're still working on our to-do list application. Today we're going to deal with sharing data using the Multipeer connectivity framework. And this is so cool because it allows us to instantly share information from one device to another using Bluetooth and Wi-Fi, and a very easy setup process. So there is no internet connection required, just a device nearby, and we can actually do that with up to 7 devices in our environment or in our vicinity. So just a quick reminder that there is the Slack workspace where we can actually talk to each other, where we can help each other out with problems on iOS development and so on. This is a free Slack workspace that I've created, and you can join using the join link in the video description below. And now let me show you how this Multipeer connectivity framework works in our to-do list application. Now, let me give you a quick overview about what we're going to do in detail. So on the left here, I have my simulator, and on the right, I have my own device that I have synchronized, or that I'm streaming right now using the Reflector software. And what I'd like to outline now is that when I press plus here, then we get something that we're already familiar with. We can create a new to-do item, and I create that now in my simulator. But now I'd like to share that with my phone on the right. And if you want to try this with your own devices, then you must have one real and physical device to test this, really. And now what I'd like to do is share this. And in the top left corner, we have this share button. And here I can either decide that I want to host a session or join a session. So I'm saying that I want now to join or to host a session here on my simulator, and on the iPhone, I'm also pressing this share button, and I'd like to join a session. And as you can see, my MacBook Pro is now listed here. I can press on that button, hit the accept button that the iPhone wants to connect on my simulator, and then it says on my iPhone that we are indeed connected. So I press done. And what I can do now is simply press the share button here in my table view cell, and we should get an immediate feedback on the iPhone. And indeed, we have successfully shared this item from the simulator to the iPhone, and this works the same way in the other way around. So if I create an item on my iPhone and hit the share button, it is added on my simulator. So this is what we're trying to create now, and therefore you can download the starter project in the video description below, and then let's get started opening up that project. And with our project open, let me just quickly recap what we did so far. In our main storyboard, we created a prototype user interface that already includes many of the features that we're going to implement. So we have our plus icon here in the top right corner in a navigation bar, and with that we're triggering an alert controller that displays an input field for our to-do item. We have this custom table view cell here that can hold the to-do item label, a complete button, and a delete button. Once a user taps on one of these two buttons, we're actually using delegation and a delegate and a protocol here actually in our table view cell to tell our to-do table view controller when a user requested a delete here in the did request delete function, and when the user did request a complete action. This is what we did there, and we also implemented all of the logic to actually do what we want this user interface to do. And we also created in the first tutorial a data manager together with the model for our application, for our to-do item application. This is the to-do item model that stores all the information in a struct, and using the data manager, we can store all of that stuff on disk. So with that being said, let's move back to the main storyboard and extend our user interface a little bit with another button. So I'm typing button into my object library, adding that to my table view cell here, and I'm just going to call that button share and place it directly in a center and on the same height as my two other buttons. And I also use auto resizing masks to actually pin that to the bottom of the cell. And what I also like to do is add a bar button item. This is also already available here because I just entered button here, and I want to drag that to the top left corner, and I'm going to select here is action so that we get the standard action button right there. And now we add some more features or more functionality to our classes. So I'm going to click on my share button now, opening up the assistant editor and making sure that I can select in the jump bar here at the top my to-do table view cell, because we need to add an IB action also for this button. So I'm pressing Control here, dragging that under my delete to do, and this is going to be an action, and this is going to be share to do, and connect that, and with that we have the proper IB action for this button. And I'm also going to add yet another function to my protocol here, which is going to be function did request share, also with the cell as a parameter. So this is going to be a to-do table view cell, and then we can also copy the logic here from the to-do, delete to-do, for example, and just paste that into our share to-do function. And then when we have a delegate object available, then we take this delegate object and call the did request share. And what we'd like to add here as a parameter, of course, is self, just as we did with the other two delegate functions. And if I build that, we're going to get an error here. One is because I have not selected the simulator, so let's build that really quickly again. And the other error is due to the fact that our table view controller does not implement all the required functions. As you can see, if I hit the fix button, then we now also need to implement the did request share function here. And let's scroll down a little bit here. We have the did request delete, did request complete, and now we're pasting the did request share here and build that, and we should be good to go. And the last thing that we need to connect with our user interface is the share button here, or the action button. So I'm opening up the assistant editor again, make sure that automatic and the table view controller is selected. And right below maybe the add new to do function, I'm now also adding an IB action for this share button. So let's maybe call this show connectivity action and select an action as connection type and hit connect. And the reason why we're calling this show connectivity is because we have two options that we'd like to present to our users. We can either join a multi-peer connectivity session, or we can host a session. And one of two users definitely needs to host a session, and the other one has to join, and we're going to make that happen using a action sheet. I've already prepared some code for that so that we do not have to write that right here. So this is just creating an action sheet with a title to do exchange. Do you want to host or join a session, and so on. And then we have, let me just quickly delete that because we want to do that right now. And then we have two actions here. We have one action that can actually host a session, and the other action that joins a session, and a cancel button just if the user mistakenly pressed on the action button. And in order for that to work, we first of all need some more properties here in our class, and we also need to adopt the multi-peer connectivity delegates and also the multi-peer connectivity browser view controller delegate. And for that to work, we also need to import the multi-peer connectivity framework. And the multi-peer connectivity framework is really great because it can use both Bluetooth and Wi-Fi to actually share information between two devices or even more devices. So you could join multiple devices could join our session and exchange to-do items. And I'm going to show you how you can deal with this data incoming and how to send this data in a second. So this is really a cool framework. But before we actually dive right into these delegate functions that we need to implement, let's first of all specify some more properties right below our to-do items collection here, or the to-do items array. And the first thing that we need is a so-called peer ID, which is an MC multi-peer connectivity peer ID that represents your devices in our session. Then we, of course, also need a session. So this is a multi-peer connectivity session. Let's just use MC session here. And the last thing that we need is an MC advertiser assistant, which is also from the multi-peer connectivity and advertiser assistant. So these are the three properties that we really need. And then we also need to conform to both the MC session delegate and the MC browser view controller delegate. And if we now build that, we'll get a bunch of errors because we have to adopt the required protocol functions. So let's quickly fix that. And as you can see, these are quite a bunch of functions here. I'm going to take all of them, cut them out, and then paste them here at the bottom, removing all of the code that I do not really need, adding a comment here with a mark, and this is going to be MC delegate functions. And paste them here, remove the placeholders for the code, and we're going through these different functions later after we have added the necessary code in our action sheet. And also did this setup for multi-peer connectivity, or to use multi-peer connectivity. We're going to write a new function for that right above load data. Let's maybe call that set up connectivity, and directly call that here after or before view.load. We can do that directly after the call of super view.load. And here we need to do three things. The first thing is to actually create a peer ID by using MC peer ID and just initialize that with a display name. And for that display name, you could use any string actually, but it's of course to your advantage if you use something like UI device and current and the name of the specific device. And then we also need the MC session. So we're also going to initialize that with the MC session initializer. And here we're going to use a peer ID. This is the one we already created. The security identity, which is nil in our case, but we want definitely encryption, so we make this required. And with that, we've created our MC session object and can use that later. And we also need to set the delegate for our session. So MC session delegate equals self, because we have adopted all of the necessary protocol functions here and add them to our class. So with that, we have actually set up the multi-peer connectivity framework, and we can now go down to our share sheet, or to our action sheet here, and first of all deal with hosting a session. And to host a session, all we need to do is, using self here, since we're in a closure, use the MC advertiser assistant and initialize that right here. So MC advertiser assistant, and initialize that with a service type, discovery info, and a session. And the service type is just a string that we have to add here, for example, Brian Advent to do. And for the discovery info, we use nil, because we do not need to specify anything here. And for the session, of course, self and the MC session. And with that, we've created our advertiser assistant, and we can now use this MC advertiser assistant and just start advertising our device so that we can host a session. And joining a session is also fairly easy. We can use the MC browser view controller, which is really cool because this does all the work actually for us. It displays all the devices that are available, and we can hit connect. We see if we are connected, and so on. So let's use a new object here, MC browser. Let's initialize that with MC browser view controller. And to initialize that, we're using the initializer with the service type. Here we're entering the same string as we did before. You can, of course, choose your own service type string. And for the session, I'm using self and our MC session. And with that, the browser is actually configured. All that is missing now is setting the delegate. So for the MC browser, we also need the delegate to be set to self, since we're also having the delegate functions for the browser in this class. And then with that done, we can use self and present a view controller just as we would with any other view controller, and just passing along the MC browser. We can tell it to be animated, and we do not need a completion handler here, so just passing along nil. And if we now run this in the simulator, we should already be able to see our action sheet, and there it is. And here I clicked something I actually did not want to click, so let's do this again one more time. So here is the action sheet, and I can click on host a session, and I can also click on join a session, which brings up our MC browser view controller, which is really great. And you can see that we can choose up to 7 devices here, invite up to 7 devices here to work together with us. But at the moment, there is no other device that could connect. So let's cancel here and see that nothing really happens. And this is because we need to implement some functionality in the proper delegate functions. So let's scroll down a little bit here. And as you can see here, we have browser view controller did finish and browser view controller was canceled. And in both cases, what we'd like to do is just dismiss this browser. So let's just call dismiss animated true and completion nil. And let's do just the same thing for the browser controller when it was canceled. So in both cases, we just dismiss the view controller and we are done. So what about the other functions here? As for the did finish receiving resources with name, we do not need that because we are going to use data and transfer data, a data stream. And we also do not need to implement did start receive resources with name because we're not doing this. And what we also need to do is using did receive stream, since we're using a data object and not an input stream. So we are going to focus our efforts completely on 2 functions here. The first one being peer ID did change state, and the other one being did receive data from peer. And for the session peer did change state, we're just implementing a simple switch statement, which I have already prepared here. And this is really pretty simple. We have the switch state going through each of the different states that are possible, like connected, connecting, or not connected. And we're not displaying that in the user interface. We could even do nothing here in this function, but if we are working with a better design later, then we will display this information to our users. But for now, let's now think about how we can actually receive data and what we can do with it. And first of all, what we should do is actually getting or creating a to-do item. So this function is called every time we start or when we did receive a complete data package from another device. So we have this data and we can now convert that into a to-do item. So we're creating a to-do item object here. So we're just using our JSON decoder here, as we did in the first tutorial when we dealt with data here. And using that decoder, we're calling the decode function for a specific type, which is in our case the to-do item type. So I have to add a .self here from a data object that we have here. And this can throw an error, so I have to try this. So we just put that into our do block here and add a catch statement or a catch block, and just throwing a fatal error here again and tell us that we're unable to process the received data. And some of you have mentioned in the comments under the last video that fatal errors are not preferable. Of course, we're just doing this here to save us some time and not focusing on the error management here too much and how we could return a nil here or an optional, and we're just focusing on the task that we had here in mind. Of course, when you're doing an application for release, then you should always handle errors properly and not just throwing fatal errors. This is actually just something that we do during development. So now with our to-do item in our do block, what we can do is use our data manager, first of all, and save this receive to-do item to our disk here on the device that receives it. So we're using the data manager and just save our to-do item. And the string or the file name is going to be the to-do item, its identifier, and its UUID string so that it has just the same file name as on the other device. And with that actually done, we can reload our table view, and we're doing just a quick dispatch queue here with the dispatch queue main, and we perform this asynchronously since this triggers a reload of the user interface. So we're just calling load data right here, and this just saves us some time here when we append a self at the beginning, because in that way we do not have to insert the to-do item at the correct position, because it is possible that the to-do item coming from another device is somewhere in between the others because it has another creation date, and this just triggers a reload and makes our lives a little easier, and we could do that nicer, but let's just keep it that way right now. And with that, we can actually already deal with receiving data. And this is as simple as that, receiving the data and then processing it. And since we used the codable infrastructure here for our struct and our data model, we can simply decode that data and save everything to disk with our data manager. So very, very simple in the way we planned that. So this is really cool. And now that we can actually receive information, we should also think about sending information. And for that purpose, we're going to add a new function, maybe below the proper delegate function that we have already implemented here, where we say did request share. And now we are going to add this function called send to do. And this is going to receive one parameter, which is a to-do item of the type to-do item. And now what we have to check is if we want to send an item, then we should also be connected to someone. So in that case, we can check that using the MC session and count the number of connected peers using its count property. And only if this integer is greater than 0, then we are indeed connected to other devices and we can send information. And now let's just do an if-let statement with the to-do data and create this data or get that data from our data manager. And therefore we already have a neat little function called load data from a file name, and this is something that we can get by accessing our to-do item parameter, its item identifier, and its UUID string. And with that, we are loading the to-do data into this object, and if this works, we can again use a do try catch statement here. What we want to try is using the MC session, calling the send function. Here we have to specify the data object, so this is going to be our to-do data object, and we want to send that to the connected peers, to all the connected peers. So we're using the MC session for that again, and just call the connected peers, which returns an array of MC peer IDs. And we do not need to specify very much here for the send data mode. We just want this to be reliable so that we also always get the correct data sent to the different devices. And since this can throw an error and we are in a do block here, we also have to catch this possible error. Again, we are making our lives easy here with a fatal error message, which is in this case could not send to do item, not toto item, but to do item. And if we are not connected to any peer, so the count is below 1, then we have an else statement here, and we print you are not connected to other devices. And with that, all that is left to do for us now is to actually share something, and we can do that in the did request share delegate function. And here we know which cell was actually pressed and which item we'd like to share, and therefore we're doing something very similar to what we already did in the did request complete and did request delete function. We're needing an index path to determine which table view cell was actually pressed, and by that decide which to-do item we actually want to send. So this is the same code, almost the same code as we used before. We're using the if-let statement here to determine the index path for a specific cell. We have this cell here as a parameter in this function. We are creating a to-do item, accessing it from the to-do items array that we have defined using the index path.row. And now all that's left is calling the send to-do function and passing along the to-do item. And we're done. And now let's just run this application in the simulator again. And let me also run this on my iPhone here. I'm not going to add that screen now. I'm just going to create a simple to-do here, or a new to-do item. I'm going to host a session here on my other device, pressing on the action button on the top left corner. I want to join a session, and I found my iPhone. So I'm connecting to my iPhone. My iPhone displays a pop-up or an alert controller and asks me if I want to accept this invitation, and we're connected. This is really cool. We have to allow this if you're using a firewall, hitting done here. And now I should be able to send an item over. So I'm just pressing the button now, and a new to-do item was created. And I can do the same thing here now with this device, and I just received that on my iPhone. So it's as simple as that. And we have created this feature in just about half an hour. So I hope you liked this tutorial about the Multipeer connectivity framework and integrating it into our to-do list application. If you liked it, then don't forget to give this video a thumbs up. Subscribe to this channel if you do not want to miss any other tutorials. Thank you so much for watching, and I'll see you in the next one.